Alright, what I want to discuss here is why we get a high voltage from an inductor when it's discharging. The circuit you may have seen this happen on is one where we've got a voltage supply, we've got a neon, and we've got an inductor. Now, what happens is we have the current flowing. As soon as we turn the current off, we get a little flash in that neon. Now, this may have been 12 volts, and the neon may have been 100 volts. So the thing we've got to ask ourselves is, why did that happen? And this is one of the more difficult ones to explain. It does come up quite a lot. Now, let's just draw the circuit a little bit differently. I'll draw the circuit like this, and this will help us understand, I think. We've got that there. We've got a possibility for, say, the switch to connect through a resistor into our inductor, and that's our circuit. So we can charge it up, and what we can do is just make sure they're all connected. So in position 1, it can charge up. Position 2, position 3. In position 1, we charge it up. Position 2, we discharge just to the air. Position 3, we discharge back through the circuit. Now, what happens is, if we all know about the charging. Hopefully we all know now that an inductor is going to produce this didt, all based on the fact of Faraday's law, which was change in flux dt. Now, we all know that when the flux changes, that little inductor there is going to produce a voltage to oppose that change, and cause a current to flow to cause a flux to oppose that change. So when it's connected in the 1 position, this circuit here, the inductor has a current flowing through it. The curve will have been, when it got charged up, this is for 1, it will have been like that, the current gradually getting up to maximum. But after it got up to maximum and stayed stable, there's a high flux in there, but it's not changing, so there's no voltage there. When it was charging up, it will have produced a voltage to oppose this voltage, right? So when it was charging up, it will have produced on the inductor there. So in the 1 position, it will have produced a voltage like this to try and oppose that one. That's when it was charging. Now, when you suddenly release it here into number 2 or to number 3, the current's going to disappear, right? So it's going to try and produce, so in 2 or 3, it's going to produce a voltage the other way around like this. It's going to try and produce the same current to try and keep the flux sustained, which is now dropping because the current got switched off. So I think you probably understand that bit just from your normal classes. Well, you probably understand everything, but this video will help, maybe help if you were struggling with it. So you flick it onto 2 or 3, it's going to produce that sort of voltage. But why is the voltage high enough to give you the 100 volts? Now that depends. If you do it through 3, the voltage will be the same as the charging voltage, 12, because it will have discharged just through this resistor. Alright? Now, we know that the discharging curve for the voltage, or we should know, I'll do another little video on the charging discharging curves for inductors, is going to be like that. That's the discharging curve. Now, what we're saying is the voltage, when we discharge through number 3, is just going to be 12 volts. When it discharges through number 2, it's going to be high enough to light that neon. That's because what's happened is the resistance in the circuit has changed. And we know that the time constant for an inductor is L over R. So if the resistance increases, the time constant decreases. So the time constant gets decreased. If the time constant decreases, this curve gets steeper because the time constant is much smaller. So if that happens, then we get di dt increases. It's negative, but it increases. If di dt increases, then epsilon, or the EMF, sorry, increases, and that's the voltage. So this is the sequence of events that produces that bigger voltage. All you've got to see in this graph here is that when the circuit just gets broken like that, it charged up with very little resistance. Maybe there was just a little resistor there, or we could call the resistance in the coil itself the resistance that's in series. But when it discharges, it's discharging through the high resistance neon bulb, and that's going to produce a high voltage. And if it produces 100 volts, you'll get a quick flash out of that little neon. Where does the energy come from? It comes from the energy in the field on the inductor. Remember, with capacitors, the energy came from the capacitance. So we had the capacitance 1/2 QV, with the inductor the energy 1/2 L I squared. So the energy comes from the magnetic field with the inductor, and it comes from the electric field with the capacitor. Quite interesting.